Hello everybody, in this video I would like to show how I build a wind speed sensor that is also called anemometer or something like that. I 3D printed most of the parts and I created this part in the way that are easy to print and has less possible support needed. The additional parts beside the 3D printed are some bolt and screw. This is M3 sides, and then a couple of very small ball bearing which have the diameter of 3 mm inside. And then we have the sensor. This is a light sensor. It's the type that is used in the motor to measure the speed. And then also we need the cable that at the end will connect to our system. The system I use to connect this sensor is the iDOSys 4, which is an open source software. So let's start to see some details about the small pieces. So we have these ball bearings, as I said. This is very small, and the outer diameter is 6 and the inner diameter is 3, and we need 2 of them. Then we have M3 nuts and then the M3 bolt, and this is, let's see how long this is, 32 mm. Okay, then we have this one. This is the sensor. This is a very common sensor, can be found anywhere. So now let's see the 3D printed part. The parts are exactly placed in this way, coming out from the printer, so they need less support. And now let's start to mount it. First thing that we have to do is to clean these holes here and here, because we have to put the ball bearing. So I already cleaned them, and the ball bearing should fit inside quite easily, but still tight. Okay, so the first is done. Let's put the second inside here. And the end result should be this one. You can see there is one ball bearing on this side and one on the other side. Now let's take the bigger part, and we have to put the bolt here and the one on the nut on this side. You can see here there is already a shape on the nut, so it should fit inside. And this is the result. Okay, so we place both together, and if we check, it should turn quite easily. Yeah, you see? Yes. Make sure that you clean this part and also this part. Then we have to put the sensor, and there is a specific location here, in this way, and we can slice inside this way. But before sliding inside completely, with a little patience, we have to screw this one inside the bolt and to add the other nut. So let's try to do it. Here we have the bolt now. Let's tighten it a little in this way. So in this way we screw the bolt and that small disc, and at the same time we push the sensor down. And the end result should be this one. We have the disk passing through the sensor, and then when the blades rotate, it activates this sensor. Okay, now I connected the cable to the sensor, as you can see, and then we had to put the bottom part. There is a hole for the cable. Here we are, and then we put all the cable inside until we get here, and this one just snap inside the other part. Here we are. And here we have the final assembly. I also had 3 screws here, here and here to keep the bottom part attached to the body. And now it's time to test it with some wind, and then connect it to the Hydrosys 4 software and check some data. I connected the sensor to the Raspberry around 3 days ago, and here we can see the result. The graph is indicating the speed of the sensor, and as you can see, it gives an idea of the wind speed. Of course, it's nice to have this beautiful graph, but the most important thing that I want to use is the fact that if the sensor reach a certain speed, it will trigger an interrupt on the Raspberry, which will cause an action. And in my future implementation of the greenhouse, I will use this trigger to close the greenhouse windows. Indeed, I have also an idea for the sun shading, but this may be another project. Anyway, let's go to the Hydrosys 4 setting page to see how the hardware has been set. Let's search for wind. Let's just see the last 2 rows, which are relevant to the wind interrupt and wind sensor. And let's start to analyze the wind interrupt. Okay, this is the row. The wind interrupt is needed to set up the interrupt on the Raspberry, and in case it can be used to trigger the events to start some actuator. Let's see how I set up it. So we have IO type is input, pin 2 is not necessary, direction is there. Okay, measure is event. Okay, time, this is 30 minutes, but it's not used in this case. No particular use. So frequency, okay, this is 3000. This is important parameter because in this way we say that the Raspberry should consider this as a fast input. Then we have this controller command with read input pin, which indicates this is an interrupt. Then scheduler type one shot means it's not going to be periodically display in the graph. Then we have logic positive. It means that the GPIO pin will be configured as a pull down resistor. Then the pin is the actual GPIO pin, which has been connected to the sensor. Then the name. This is a name to remember it. And that's all. So when we set this row, it is going to set an interrupt on the Raspberry. And in case we want to also trigger some action, we can configure it in the interrupt page. Then, as I said, we have another row that is wind sensor. This row is necessary when we want to have a graph with the frequency counter of these interrupts. First of all, this is the controller command, so it's interrupt frequency counter, as I said, and the time. In this case, we have 2 minutes, so every 2 minutes it will give a reading. Then another important thing is the pin should be the same of the interrupt pin. And then the scheduler type is periodic because it will periodically collect the data. And that's all from the hardware part. So let's go now to the interrupt part. And let's, for example, set the interrupt trigger to send an email every time the sensor reading is above a certain speed. So we will go to Mail and select the working mode. In this case, is only one, is preemptive blocking. Then reference input, we had to use the wind interrupt input. And then activation mode, we can use first edge. Indeed, the sensor can accept either first edge or second edge. And then we have event trigger. So trigger mode in this case is, there are two modes. In this case is frequency, so it means the speed. The next field indicates the number of interrupts to trigger an event. And for example, I put in this case 100 interrupt, and this is connected with the second field, that is max time between interrupt, and this is 2 seconds. It means that the event is triggered when we get 100 interrupt within 2 seconds. Then actuator output, in case of mail, as I selected before, this needs just to be a number above 0. And then duration of preemption blocking status, this means that after the trigger is set, it can stay a number of minutes without activating. And then follow-up action I didn't set because it's not needed in this case. After that I save. So with this configuration, every time that the system reads 100 interrupt within 2 seconds, will send me an email. I hope this video was useful, and thank you for watching.